This is part 2 of my video to help you with assignment 5.2 for my online students. I have a student who lifts a 4-kilogram book vertically from rest. So here is the book. The student is going to lift it with their hand, and they're going to lift it with a force that is equal to 52.7 newtons. Um, I'm not sure how you want to draw this student, but here the student is lifting the book, and we're going to lift it a distance of 1.6 meters. Find the work done by the student. So I'm going to draw a free body diagram of the book. The student is putting a force upwards of 52.7 newtons, and I'll call that Fs for the student. I also know there's force of gravity that's acting on the book, which is its mass times acceleration due to gravity. They told me the mass of the book is 4.10 kilograms. A, work equal force of the student times distance times cosine theta. I am traveling upwards, so this is the displacement vector. The angle, so I have distance upwards, force upwards, theta equals 0. There is no angle between those two vectors. And so work done by the student is equal to the force that the student put on the book times the distance in meters, which was 1.60 meters. This is in newtons, times cosine of 0 degrees, which is 1, by the way. And that is equal to the work done is 84.3, we'll call it joules, if I plug that in properly. B, what is the work done by gravity? Well, work done by force of gravity times the distance times cosine theta. Well, again, the displacement is moving upwards. Gravity is moving downwards. This is 180 degrees. So the work done by force of gravity is its mass times g times d times cosine of 180 degrees. So the mass of the book is 4.10 kilograms times 9.8 meters per second squared times 1.6 meters times cosine of 180 degrees, which is -1, by the way. Make sure your calculator is in degree mode. Okay, 4.1 times 9.8 times 1.6 times cosine of -1 gives, or 180, which is -1, gives me a negative 64.3 joules. So work done by force of gravity, work done by the force of the student. This is a positive, this is a negative. B. All right. The final speed of the box. C. B final equals question mark. Work net is equal to the change in kinetic energy. I know the work net. Work net is equal to the two works of these added together. So it will be 84.3 joules plus a negative 64.3 joules, or subtract it. And that will give me 20. We'll call it 20. Oops. I lost my page. Where'd it go? So the net work is 20 joules. Well, if 20 joules is the net work, that will equal its kinetic energy final minus kinetic energy initial. It started from rest, so we're going to continue filling in all the things we know. 1/2 the mass times v, the velocity squared, the final velocity squared, subtract the initial kinetic energy, which is 1/2 the mass times the initial velocity squared. Well, the initial velocity was 0 because it started from rest. So I'm closer. I've got to rearrange this equation for final velocity. And what do I get? I get final velocity squared is equal to 2 times 20 joules divided by the mass. And the mass is 4.10 kilograms. Notice that's velocity squared. Have to take the square root of both sides. I find the final velocity to be equal to, let's double check. I get 40 divided by 4.1 and take the square root. 3.12. Okay. All right. And then one more to go. This is not an easy one, just so you know. Again, what are we using? We're using these principles. We're using the definition of kinetic energy, which is 1/2 mass times velocity squared, and that we know that the total work is equal to the change in kinetic energy. Okay. We have a boy that does 19 joules of work. Work equals 19 joules. He pulls a sled that has a mass of 6.4 kilograms through a distance of 2 meters. No other work was done on the sled. That means that this is equal to the net work because there's no other work. That's the total work. Okay. If the initial speed is 0.5, velocity initial is 0.5 meters per second, what is the final velocity? Okay, work net is equal to the change in kinetic energy. What does the change mean? Kinetic energy final minus kinetic energy initial. So work net, which we know, 1/2 the mass times V final squared, that's kinetic energy final, minus 1/2 mass times V initial squared. That's kinetic energy initial. What are we looking for? We're looking for V final. Here it is. I got to rearrange this equation and get V final by itself. I don't like working, I can't cross anything out, by the way. The initial velocity is not 0. So I don't like working with fractions. So I'm going to multiply the left-hand side by 2 and the right-hand side by 2, and I'm going to get rid of those fractions. So I get 2 times the work net, which we know is 19 joules, and we'll fill that in. The half goes away in both of them because I've multiplied by 2, and I'm getting closer. Now I'm going to move this over to the left-hand side by adding it to both sides, which will give me this. I'm getting closer. I still don't have V final by itself. I'm going to divide both sides by mass. That will cancel mass on the right-hand side. And notice what else I need to do. I got to get rid of that square root. So I'm going to take the square root. So my final equation will be the velocity, and this is final velocity, is equal to the square root of 2 times the net work plus the mass times the initial velocity squared divided by the mass. And I can plug in all my values, which is 2 times 19 joules plus the mass, which was 6.4 kilograms, times its initial velocity squared, which is 0.5 meters per second. I'm going to square that. Don't forget it, the square, or it'll be wrong. Divided by the mass again, which was 6.4 kilograms. And if you plug that into your calculator, and if I did that correctly, I get 2.54 meters per second. So let's try again. 2 times 19 plus 6.4 times 0.5, and I square it, divided by 6.4, and take the square root. 2.5. I got a slightly different number, so I'll call it that. Okay, that's what I got. Hopefully that helps you. Reach out to me if you have any questions.